we're going to talk about accuracy and precision. Most people kind of take those two words and use them interchangeably. Why is this not recording? Okay, it is. Okay. So the difference between accuracy and precision is with accuracy, you need to have some sort of accepted value. Okay. So your value needs to be something that's been published and has been tried over and over again. For example, the density of water is 1 gram per milliliter. Okay. So that is an accepted value. If you went out and measured the density of water, as you're going to do in your first lab, you might get a value that's like 0.97 grams per milliliter. Okay. So you could see how accurate you are based on that accepted value. Okay. Precision then is how close your data is to similar experiments. Okay. So when you do that density of water activity, you're going to be taking the density of water 6 times. Okay. If your numbers are all very close together, then they would be precise. They may not be accurate. If you ended up getting 0.75, 0.76, 0.78, your numbers would be precise, but they wouldn't be accurate. Do you see the difference between that? So if you're like a quarterback and you're throwing the ball, okay, and you've got a target that you're throwing it at, they have like competitions sometimes where they do that. You know, they're trying to hit it through a hula hoop at, 50 yards away. Have you seen those before? Okay. So let's say that you're a quarterback and every time you hit it through that hula hoop, okay, you are accurate and precise. Now say you're another quarterback and you're throwing it and every time it lands over there in the same spot, but it's not in the hula hoop. That would be precise, but it wouldn't be accurate. See the difference between those two pieces of data, okay? And so we have like targets here, okay? This one is not precise or accurate. Same here. This is very precise, but it's not accurate. Here, it's both. Okay, did you have targets that you have to fill in on your sheet? I think you do. So I will give you a minute. This is precise and accurate. These are neither. It's pumpkin spice season, you guys. All right, anybody need more time with this slide? Good? Okay. All right, so here we have some data. Do you have this data on your sheet? I believe so. Okay. So I want you to look at this data and try to answer a couple questions. First of all, which student up here is most precise? Now for that, you don't need this accepted value. You're just looking for the data that's the closest group together. For accuracy though, you do need this accepted value. So here is your accepted value. You're going to figure out which one is more accurate based on that. So is that student's the most precise, is that accurate? And then if not, which one is the most accurate? So spend a minute just kind of looking at that data and see if you can come up with an answer for that. All right. Anybody want to give it a go? Which one's more precise here? A, B, or C? C is most precise. Good. And that was Bella, right? You go by Bella? You go by, no, shoot, Jenna. You're Bella, right? You go by Bella?
I go by Izzy.
Izzy. We had this conversation, didn't we? I-Z-Z-Y?
Yeah.
And then Jenna's next to you, right? Okay. I'm getting there. You guys, I told you it's going to take a while. All right, so student C is most precise. Their answers are clustered the closest together. Are they accurate? Let's see. That would be Presley, right?
Yeah. They're not the most accurate.
Good. And, right. And who is? A. Good. Do you see the difference between accuracy and precision? No? Okay. That's Aurora, right? Okay. Let's see. I had found another one today where we're looking at accuracy and precision. So, I think here they were trying to throw the ball 50 yards. Okay, so going across here, we're seeing who's most precise and who's most accurate. If they're going for 50-yard line, who's most precise? So precision is where they're clustered close together. Okay, so if we look here, hi, Mr. Watson, how you doing?
Can I see
Tristan? Yep. So do you see how students see here? Everything's very close together. It's all clustered around. The average here would be like 1.7. Okay. Here, they're off quite a bit. This is 0.04 that they would be off. And here, they're just all over the place. So this is not precise at all. Now, when we're looking at accuracy, we're comparing their answers to an accepted value. So accuracy accepted, okay? This is accepted. This is what you want. This is the goal. And this guy, A, would be the closest to that goal. Even though this guy's, like, his grouping is good, he's very consistent with his data, but it's not right, okay? Here, you're going for accuracy. So accuracy is the accepted. So remember the A and A, accuracy accepted. Good? Make sense? Okay. All right. So that takes care of that. Now we're going to talk about something called scientific notation. Some of you might have had this in math class, but oftentimes this is your first kind of experience with it. And when we do scientific notation, what you're doing is you're taking a number, the number that you're given, and you are moving the decimal point, just like we did with metrics yesterday. You're moving the decimal point one way or the other until that first number is between 1 and 9. So for example, here is my decimal point. I'm going to move that decimal 1, 2, 3 spots. So that's going to be 1 times 10 to the 3, because 10 to the 3 is what? Is 1,000. Okay? And if I multiply 1 times 1,000, that equals 1,000. Okay? This is used for really big numbers and really small numbers. So for example, we talked yesterday about the mole. Remember we had that as the amount of substance. That was our metric unit for amount of substance. And that number is 6.02 times 10 to the 23rd. So this is a really big number. And instead of having to write that out, that would be how I would have to write it out. Okay? That is a stupid big number, like to try to work with. This is not so daunting though, is it? And I'm going to show you how to enter this into your calculator in a couple minutes, because your calculator can do the work for you. Okay? Now, we can go and do the opposite when we are working with smaller numbers. So here, we move our decimal point 3 spaces this direction. If we move it to the right, then that becomes a negative exponent. And I'll show you how to put that into your calculator as well. It's going to involve me running around a lot though, so you're going to have to be patient with me. Okay? All right, so here we're going to talk about how we're going to add and how we're going to multiply with this. So the first thing we're going to do is we're going to add. We're going to add this number to this number using your calculator. Okay? Let me show you how you do that. You are going to want to, and I don't want you to, but you're going to want to grab this key to do it. Avoid that. Okay? For the most part. Now, some of you, we may have to do that depending on what calculator you have. I am going to start out using the calculator that Macy has. Macy, can you hold up your calculator and show them your calculator? If you have a calculator like that, you are going to listen to me right now. Okay? The rest of you that don't have a calculator like that, and that includes Hayden. Hayden, hold your calculator up. This is Hayden's calculator. If you have a calculator like Hayden, you're going to listen to me right now. Okay? So what you're going to do is you are going to press the 6, the decimal, the 0, the 2. So press that in. Then you are going to go up to the top part of your calculator here. You're going to find a key that says second. You're going to press that. Then you're going to go right above the number 7 key, and it has, what does it have on that? What's right above the 7? Yeah, you're going to press that button right above the 7. That's a comma. Okay? And what you've done is you've activated a feature in there that is EE. Okay? So your calculator screen right now should say 6.02 E. If it doesn't and you have one of these calculators or one like Macy, call me over. Okay. Then you're going to type in 23. And that's for this. This E key right here is telling the calculator that you're raising this up to the power of 10. And yeah, I know you've got a key on there that you really want to press that looks like this, but there's problems with that. So avoid doing that, please, and use this E key. Now you're going to go and you're going to press the plus key. Then you're going to repeat the same process that we just did, but you're going to enter this number in. So 2.54. You're going to hit the second key. Then you're going to activate that EE by pressing that comma key. Your screen should say this now. And then you're going to type in 24 and hit equals. All right, you should get an answer back for this. That is 3.052 times 10 to the 24. Instead of the times 10 to, though, it's going to have an E here. All right. Anybody have one of these calculators that wasn't able to get that answer? Everybody cool? All right. So I want you to try to do the next one. Now, when you do the next one, there is a difference between the minus key and the negative key. This is minus, this is negative. All of your calculators, no matter what kind you have in here, you're going to have a minus and a negative. So make sure you're hitting the minus key in this instance. So see if you can do that answer. Now, the rest of you, I handed out a bunch of calculators. Was this one that I let you borrow? Okay. So if you have a calculator that I handed out to you, the TI-30X, or any kind of TI calculator other than what I just went through, you have the EE key that I was talking about. It's right above the number 7. Anybody have a Texas Instruments and you're not able to locate that EE key, call me over right now. Casio's we'll get to. We're not to Casio's yet. That's a Casio. Oh, we're doing Texas Instruments right now. Anybody not able to find the EE key? Yep. Right. Okay. Your EE. That's. I know it doesn't say EE, but that's what you're going to use. Okay. Yep. That's why I do a lot of running around on this day. So I want to make sure that everybody's good. All right. So those of you who have a Texas Instruments, you're going to do the same thing. You're going to type in the 6.02. You're going to activate that EE key, type in the 23 plus, and then continue over. When you do that, if you don't get this as an answer, I want you calling me over. You have to learn to use these calculators, so you need to call me over if you're not getting the right answer so we can take care of this. Yep. Yep. 24. Yep. And then there's your answer. And then you just have to know that that means times 10 to the 24 when you write it down. Yeah, we're not to Casio's yet. I'm just doing Texas Instruments. I'll get there. So 6.02. And then this is your second key right there. And see how that's in the blue? It's in the same color. That's your E, 23 plus 2.45. So just 6.02. And then hit your E, and then type in your 23. No, don't. No, just 23. And then plus 2.45. And then your EE and your 24. No, just 24. The EE means times 10 to the. So it's taking care of all of that for you. It's a much faster route to go. Okay? Yep. But you're not writing it like that. You have to be smart enough to know that when you see that, you write that down. Okay? So your calculator will do the work, but you gotta be smarter. All right. Anybody else with the Texas Instruments that I need to help? I haven't gotten to the Casios yet. I'll get there. Okay. 6.02. You're going to hit that EE and then 23. And then plus 2.45. 4. Yep.
That's wrong. The song I had like 3.1.
Yep.
Oh, 1.
Okay. Anybody else for the Texas Instruments? All right. Now, Casios. Casios, you have down at the bottom probably either a 10 to the X or an EXP key. Anybody with a Casio that can't locate that key, call me over. Okay, so when you type it in, you're going to do the 6.02. You're going to hit that EXP key at the bottom, and then you're going to type in 23. Then you're going to hit plus. And then your 2.45. And then that exponent key again, and then 24. And then you should get that as your answer. If you don't, call me over. You good? Yeah, this is what you got. That's the right answer. Well, that's going to be a different answer. That one is 8.6. This is your minus key.
Yeah, that's what I got.
Yeah. I do.
All right. You ready for the next one? All right. So next one, you're going to type into your calculator. We're going to talk about the answer on that one, okay? So it's 8.26. You're going to hit second EE or your EE key or your exponent key, whatever it is for your calculator, minus 2.45. And this is what it's going to kick back for your answer. Okay, and we're going to talk about how we put that into scientific notation here in a second. I want to make sure everybody can get that as your answer. Anybody not able to get that? So type in your 8.26 with your exponent key and type in the 5 minus, and then type in 2.45 exponent and 4. Yeah, that's your answer. That's what I got up there. Okay? Anybody not able to get that on your calculator? I need everybody playing along with me today. Use this all year long in here. All right. So how do we put that into scientific notation? My decimal right now is at the very end here. Yes, everybody buy that? Okay. I need to move this over until the first number is between 1 and 9. And I'm going to count how many times I move it. 1, 2, 3, 4, 5. So when I write this out, what am I going to have for my exponent here? 5, because that's how many times I moved it, and I moved it to the left, so this is a positive value. Everybody cool with that? All right. We are going to change this problem. Are you okay with me changing something on you? Okay, I'm going to make this a negative 15 here. I want to make this a negative 15 because I want to show you the difference between a negative key and a minus key. So see if you can calculate this and come up with the same answer that I have. And I've got to get that. So just give me a second to punch that in. 5.63 negative 15. Okay, so this is what you should come up with for your answer. 4.08. We're just going to go to the hundredths place today, times 10 to the negative 6. Now, this you may have problems with. I need everybody in here to get this answer. 1, 2, 3, 4, 5, 6 is what I said. Yeah. So what you do is you just take this decimal and you back it up. See, I'm backing it up 6 spots there to get to there. And that's your negative 6. Yep, EE and then the negative. Yep, that's why I want you to practice this. Yep, that's the same one, because see it says negative 6 up there? Good, good, all right. Yes, So here you didn't put in negative. Okay, now this is so you can toggle up, grab that. You can toggle over and hit insert and hit second. And then you're into like negative negative. Now.
Oh, I get it. So then now I don't have the 6.
Otherwise, you can do that. All right, who was not able to get that? Call me over. We need to spend, we're spending time on this. We need to do that to make sure you got it. Okay, so the negative is right there. You good? Yeah. Okay. All right, anybody else? You've got to get intimately comfortable with your calculator. And I know that it's kind of boring today, but you've got to do it. Huh? Don't blow this off. Ask for help, please. Or is it on this one? Okay, 7.25. And then the EE key, and 8. And then times 5.63. And then the EE key. And then now you're going to hit the negative key, which is below the 3, and that's a minus. There you go. Yep, that's your negative key. And now you're going to type in 15. There you go. Okay, now if you count here and back that decimal up until this number's right there, the decimal there, you're going to count 6 spots. So that's where we got the negative 6 from. See, it says times 10 to the negative 6. Okay?
So do I write that out?
Yep, you write it out. Yes. You format it properly. Yeah, I think I rounded the tenths. Or hundredths. All right. How are we doing? Can I help anybody else before we move on to the last problem? You have to get help for this if you don't understand it. You will sink very quickly in here if you're just kind of like, whatever. I don't need this. You need it. Okay? Trust me. All right, last one. Let's see if we can get the answer for this one. 15 divided by 4.933. All right, so I got this for my answer. If I did it right, 315. Pretty sure I did. So 7 point, and I'm going to round this to the 100th spot, times 10 to the 11th. Good? Anybody not able to get that answer, call me over, please. I will literally get down on my knees and beg you if I have to. Divide. Yep. Good. 100 this time. Anybody else? Please let me help you. Yeah, I just rounded it up. The 9 is the cost that. No, you got I may end up marking it wrong because if they're not here with the W, like if I do, okay, if I do, call attention to the fact that, you know, you're not from here, you know, you do it differently, and that's okay. I'll change my grade, okay? Okay, all right, thank you, good. Okay, but I may forget, and I do a whole pile of data. Just so I get comfortable with that. But I recognize that it's the format that you guys use over Spain. Yeah, in Spain, and that's okay. It's not an issue. But I sometimes forget, so it's my fault, it's my issue, but you may have to say, hey, you did this wrong, fix this, okay? So just know that I will. You just may have to call me on it. Right up front there, you got your ID? Oh, you got that. Yeah, that's everyone's wrong.
Good, I guess you got.
No, don't do that. They'll eat it. And then you try and then go from there, 3. And then your EEP. And then the 3. There you go. Anybody else? Let me help you, please.
Yeah.
Okay, so, sorry. Oh, one more. There we go. I think I'm done. Okay. So the last thing that we're going to talk about today, and really for this week for the most part, is something called percent error. And percent error tells us how close we are to an accepted value. So this tells us how accurate we are. Ultimately, you want your percent error to be 0. If it's 0, then that means that you are right on the mark. You got exactly what the accepted value was. And that's what your goal is when you're doing an experiment, is you want to be able to reproduce that data very well. Okay? So here is the formula for that. I believe that's in your notes, yes? Okay? So when you calculate this, notice that there are these vertical bars here. That means absolute value. What does absolute value mean? If you go back to a math class.
It's the positive version.
Okay, it's the positive version of that number. You're right. But what is its meaning? It's how far you are away from zero. It's the distance from zero, right? Have you heard that before in terms of absolute value? Yeah, it's just got a few cobwebs up there. All right, so if we're looking at percent error, here is the density of water. It is 1 gram per milliliter. This is what they got for their experiment. They want to know percent error. See if you can calculate the percent error for this. And honestly, it doesn't matter which one you put first. Okay, so if you did one, oh shoot, why did that? Oh, because I probably switched to a different screen. Okay, let's try it again. If you put 1.00 minus 1.08 absolute value over, now this is important. This has to be the accepted on the bottom. Okay, this number has to be in its correct place, but these, it doesn't matter, because if you did this, what is your top number going to be in either case? It's going to be 0.08 because it's absolute value. So I tell people to think of it as putting the bigger number first. So when you're subtracting, you always end up with a positive number. And then that'll take that out of absolute. But your accepted value always has to be on the bottom. Okay? So her percent error ended up being 8%. I ended up talking all hour. I told you it was going to be short notes. I'm so sorry. So tonight, I would like you to do the second part of your homework, and we'll do this part tomorrow, okay? So the second part of your homework was a scientific notation. Take that home and see if you can do some of that tonight with your calculator. I'll get the answer key up online. The part that you need the rulers for, we'll deal with tomorrow, okay? So in your packet, you have, you were supposed to do this ruler activity, okay? Just skip past that and see if you can do this tonight, okay? See if you can do this little bit of scientific notation tonight if you have time. I know some of you, your time is strained. That's due on Friday. You'll have some time in class tomorrow. I promise I won't talk as much tomorrow, okay?
Yeah.
Try to do that tonight, if you can. Yep. All right.